And here is the third sample problem associated with sample problem C here in chapter 4. So again, we're still working with Newton's second law, which remember, mathematically, is F equals ma. Okay, there's a relationship between force and mass and force and acceleration. It's kind of how that was originally figured out, okay, way back in the day. We could get a little bit more proper and throw in that sigma, right, for the sum of the forces, aka net force. But right now we're still only working with one force, just in general. So we're kind of giving you the sum already. So, well, let's read the question. A car has a mass, all right? So there's my mass. Okay, there's mass m. Of 1.50 times 10 to the third kilograms. If the force acting on the car is 6.75 times 10 to the third newtons to the east, what is the acceleration? So we're solving for acceleration. Again, how do I solve for acceleration? When I was little, we used to use the term, or phrase rather, get it by itself on one side of the equal sign. Okay, get it by itself. And so, that means we're going to solve for the desired term. In this case, it's a, so divide both sides of the equation by m. So I end up with an equation that looks like that. Now I have the value for force right here. Okay, 6.75 times 10 to the third newtons, and I have a mass, 1.50 times 10 to the third kilograms, and I'm good to calculate. Okay, so calculator actually tells me 4.5. That's not quite right. It's not quite right because I can see 1, 2, 3 sig fig here, 1, 2, 3 sig figs here, and that means the answer that I report needs to have 3 significant figures. And so the only way that I can do that is by adding a 0 right after 4.5. So 4.5 is 0. And again, let's and these times 10 to the 3's, right? They cancel each other out here, and so there's no times 10 to anything, right? Times 10 to the third divided by times 10 to the third, it goes away, right? It's just 1. But let's talk about the units one more time. So we have newtons divided by kilograms. Now, remember, a newton is a derived unit, which is actually kilograms multiplied by meters per second squared. And so in this setup, if I take the newton, which really is all of these units, okay, and then divide by kilograms, which is what I'm doing here, I'm dividing by kilograms, the kilograms cancel. And so the only unit I have left is the units for acceleration, meters per second squared. Okay. I only have one more thing that I need to make sure that I include. Okay, if you go back a few videos, I actually forgot to do this. Practice problem 1 from this sample problem C is the direction. Okay. The force is acting to the east, and so that's where the acceleration is going to be. And so my full answer is 4.50 meters per second squared east.